Okay, using vectors with F equals ma. So we've got two forces, F1 and F2, acting on a particle of mass 4 kilograms. So they've been resolved into two perpendicular forces. And we want to find the magnitude and direction of the acceleration. So the resultant force F is equal to mass times acceleration, and you can just extend this into vectors, so we can actually find the acceleration as a vector. The resultant force is, we looked at this before, is when you add the vectors together. So finding the resultant is nice and easy. Mass is a scalar quantity, and the acceleration will be a vector quantity now because we're working in vectors. And so adding them together, we get 13 plus 7, 20, minus 15 is equal to 4a. And so as a vector, the acceleration is equal to 5 minus 15 over 4. I'll write that as a decimal because we're in mechanics, but we'll be back to pure maths and fractions soon actually. So that's the acceleration. And then if you want to find the magnitude and direction, so that's finding the magnitude and direction of the vector. So the magnitude of the acceleration is Pythagoras. So it's the square root of 5 squared plus, we don't really need this negative here, but 3.75 squared, and that gives you 6.25. And then to find the direction, I would draw a diagram. So we're going across 5 and down 3.75. And we'll find this angle in here. So actually I'll call that alpha. You can't see that now. So I'll call that one alpha. So tan alpha is equal to opposite over adjacent. And if you do shift tan of 3.75 over 5, you get 36.9 degrees. And if you remember how we measure angles, it's anti-clockwise is positive and clockwise is negative. And so the angle this is making is negative 36.9 degrees. So it's just working with vectors a little bit more. You can also use SUVAT with vectors. So if the particle has initial velocity of minus 2.3 meters per second, find its velocity eight seconds later. So we've got u, but this time we're working vectors, so u is minus 2.3, that's why I'm underlining it. T is a scalar quantity, time, and we know the acceleration is 5 negative 3.75, and we want v, and so we can use v equals u plus AT. So it's just extending these into vector form and just plugging in. So minus 2, 3, 2 is 8, lots of A, which is 5, minus 3.75. And that gives you 38 minus 27. Meters per second. And then you can find the magnitude of that using Pythagoras and the direction using trig. Just one thing to note, if the forces are in equilibrium, then the resultant force is 0. So when you add up your vectors, you'll get 0. So if you could work through page 450, question 7 through to question 10. So it's just a little bit of work on F equals ma and see that with vectors.